Hi, my name is Anson Lau. I'm a first year at UConn. I am currently studying civil engineering. I am from Naugatuck, Connecticut, and a fun fact about me is that I enjoy anime as much as the next anime lover.
Hi, my name is Albert Cheng. I'm a freshman at UConn studying computer science. I'm from Long Island, New York, and I enjoy playing tennis.
Hello, my name is Edison Chen, and I am a freshman at UConn majoring in mechanical engineering. I am from Glastonbury, Connecticut, and fun fact about me, my favorite ice cream flavor is mint chocolate chip.
Hi, my name is David Elijah de Siqueira Campos McLaughlin, and I am a sophomore studying computer science at UConn. I'm from Cobalt, Connecticut, and I enjoy hiking a lot. I'm good around computers too and like playing Minecraft with my siblings. Now, it's time to meet the HDD. An HDD, short for hard disk drive, is a data storage device that stores and retrieves data using magnets in a rotating disk. HDDs are important because data is stored in a non-volatile manner. This means that even if the power supply is cut off, the data will be stored on the hard disk drive for when it's powered back on. They are differentiated from solid-state drives by being cheaper, though the SSDs tend to be the preferred storage system by consumers nowadays.
So here we will be talking about the history of the HDD. The HDD was first created in 1956 by one of the biggest tech companies during the 20th century called IBM. It was called the IBM 305 RAMIC, which stood for Random Access Method of Accounting and Control. The RAMIC was a huge design. It was the size of 2 refrigerators, weighed about a ton, and had a storage capacity of only 5 megabytes. It was also very expensive, costing about $30,000 in today's value. If you look at the top right picture, that's what it looks like, the RAMIC. In 1964, IBM created the first standardized disk drive called the IBM 2311, meaning this was the first time the HDD had platters which stored the data. In 1980, IBM produced the first HDD that had a storage capacity in the gigabytes and weighed about 500 pounds and could hold up to 2.5 gigabytes. Also, many new tech companies started to rise, like Memorex, Western Digital, Rodime, and Hitachi, in which they developed their own style of an HDD. IBM later sold their data storage division team to Hitachi, a multinational company in which they later developed the first 500 gigabyte HDD in 2005, and later coming up with the first 1 terabyte HDD 2 years later. If you look at the bottom right picture, these are what HDDs look like compared to ones that were made in 1956.
Like any other functioning machine and device, the hard disk drive cannot function properly without its major components. Each component plays a critical role in ensuring that it can properly read and store data efficiently. The main function of the HDD involves the actuator arm, the spindle, the reading and writing arm, and the disk's bladder storage. Throughout the presentation, you will see me taking apart the device to show the anatomy of the HDD as we focus on these 4 main components. And although this may look like a piece of hardware that sits inside your computer, we're going to show that there is much more going on in this pocket-sized powerhouse of data storage than meets the eye.
So before we dive into the internal components of an HDD, let's explore the outer components, starting off with the casing, the outer casing, which is also known as a disk enclosure. So the HDD's outer case usually comes in 2 sizes, 3.5 and 2.5 inches. Well, this actually refers to the size of its platters. However, with like a bigger internal size, the outer case must also provide more room and durability. The casing itself is made up of aluminum and plastic, which provides a strong structure to hold the components together. And the screws that are used to fasten the casing and components are made up of steel, making them more enduring and less prone to damage. Oh, and they also appear to have magnetic properties. And finally, on the sides of the HDD are 6 screw holes in total to provide a way to mount the hard drive within a designated area inside of a computer tower. Now moving on, let's explore how data is transferred. So connected to the PCB or circuit board are the ports that provide connection between the data components inside of a computer to a hard drive. And the modern method used to transfer that data between computer and hard drive is called Serial Advanced Technology Attachment, also known as SATA. The SATA data cable is used to transfer the data. So on one end, the data cable and power cable connects into the SATA port of the hard drive, and on the other end, it connects to the computer motherboard and power supply unit. The hard drive uses SATA connectors because it transfers data in a serial fashion. This means that each bit of data travels across a single route to its receiver. Each bit is then written one by the write and read head of the actuator arm, which magnetizes each bit of data onto the tracks embedded on the platter.
The printed circuit board is located on the back of the HDD. It is made of many different subcomponents, including the board itself, resistors, SD-RAM, integrated circuits which serve a variety of purposes, header connectors, and more. Each component works together to allow the HDD to retrieve information when the computer needs it. The PCB's main board is made up of 6 key components. The first important piece is the copper foil, which is used because of its high conductivity. Copper foil is etched away to create the circuitry. Sheets of copper foil are glued together using a material called prepreg, which is a sort of thin glass fabric combined with resin. Prepreg is made of FR4 epoxy, polyamide, Teflon, and other materials. When the prepreg is heated enough, the resin softens and melts, allowing it to bond to other things. Prepreg is light and yet is rigid and tough, making it ideal for circuit boards. When prepreg is combined with copper foil sheets on both sides, it creates a laminate, our third main component. To prevent the exposed copper from oxidizing, a green epoxy coating called solder mask is added. Nomenclature is printed on top and acts as a guide for electronic components to be oriented or placed. Nomenclature and solder mask can be sold in different colors, but green and white are the most popular. Wherever the solder mask does not reach, such as where the board needs to create a connection, a final finish of an alternative metal, such as gold, is used. The circuit board is covered in very tiny components called resistors. Resistors are meant to reduce the amount of current that flows through the circuit. Without these resistors, the board could heat up a lot, which has various negative effects on the board, such as cracking the circuit board when the board is heated or cooled very quickly, or melting the prepreg in extreme cases. Resistors are made up of a variety of materials depending on their purpose, including carbon and metals. You can tell more about a resistor by looking at the small colored bands on the outside. The integrated circuit board is actually a smaller circuit board placed on top of the main circuit board. Just like the main circuit board, it has several smaller components placed on top of it, such as resistors and capacitors. These are then enclosed inside of the chip to turn the collection of parts into a single component. Integrated circuits usually have a specific goal, such as acting as a clock or a logic gate. This integrated circuit, a Marvel 88I9045-TFJ2, appears to act as some sort of clock or perhaps drives the ReadWrite Head inside of the hard drive, but it is difficult to tell with a more generic IC chip such as this one. Here's a demonstration of both of these devices in action in the game Minecraft, which is oftentimes used to simulate complicated circuits such as small CPUs. This circuit is a form of logic gate. If both of these levers are on, the lamp turns on. However, if either lever is off, the lamp remains off. This logic gate is called an AND gate because both levers have to be on for the lamp to turn on. This complicated circuit also aims to turn the lamp on, this time by pressing the gray button. This circuit is called a dual-edge circuit, which means that it sends a signal to the lamp when it first receives power and when it is powered off. This causes the lamp to turn on twice with a single button press, doubling the amount of times it turns on than if the button directly attached to the lamp. This mechanic is used in real-life circuits, such as the next component on the chip, the SD-RAM. The SD-RAM, or Synchronous Dynamic Random Access Memory, is a sort of random access memory. RAM is a sort of volatile memory, which means that information is not remembered if the RAM is powered off. SD-RAM is built to be synchronized with the CPU of a computer, allowing it to send information to the CPU exactly when the CPU requests it. SD-RAM is dual-edged, meaning that it sends information when it receives a clock signal, and sends information again after the clock signal ends. This is extremely similar to the Minecraft dual-edge demonstration that I showed earlier. The SD-RAM used is a Samsung K4H2916-380. The Spindle motor controller is a kind of integrated circuit that behaves like a clock. This means that after a set amount of time, it sends out a signal. This is extremely similar to the SD-RAM, but it serves a different purpose. The SMC sends pulse of electricity to the hard drive spindle, which spins the hard drive's disk itself. This particular SMC is a smooth L7251 model. Header connectors are the way that a circuit board can communicate with other components. This particular header connector is a Foxconn HL2210PF-P0. Header pins use a lot of contact materials to make a connection, such as brass. This particular unit uses a copper alloy. The insulating housing is made of a thermoplastic which is made to withstand a large range of temperatures.
let's explore the actuator and arm, made of aluminum, and they both operate magnetically. And on the actuator arm, well, behind it is the actuator axis, and behind the actuator axis is an electrical magnetic coil, and that rests below a magnet. And attached to the whole arm component is a ribbon of wires, which then connects to the circuit board. The circuit board is the one responsible for sending electrical signals to the actuator. And when the electrical signals are sent through the wires, the coils will generate a magnetic field. The magnetic field of the coils then interacts with the magnet above the actuator arm, and because of this interaction, the arm is able to move quickly across the disk. This allows the head to read and write data at high speeds while maintaining precision. And note, the spindle will be spinning the platter continuously as well. So this interaction between the actuator arm is actually very impressive. Okay, moving on to the ReadWrite head and the platter. So at the very tip of the actuator arm is the read and write head. And while the hard drive is operating, the heads of the actuator arm actually hover 3 nanometers above the spinning platter. This is because the heads of the actuator use magnetic forces to read and write data, meaning that the heads don't have to be touching the spinning disk. The two heads actually both correspond to each other and are similar in functionality. The read head is the part responsible for reading the magnetic domains on the platter. It does this by turning the magnetic domains back into electrical currents. Vice versa, the writing head, also known as the transducer, is the part responsible for actually magnetizing those domains on the platter. In fact, both the heads also operate from a mini electrical magnetic coil, and depending on the direction of the current that's being sent from the circuit board, the head either aligns the magnetization of each domain that's on the spinning disk either north or south. North meaning that the binary digit is 1, and south meaning that the binary digit is 0. Okay, so all of this happens while the drive is running. So when the drive is not running, there is a spring located inside of the actuator axis that will bring the arm back to rest in a neutral position. The heads of the actuator arm actually later rest within a block of plastic to prevent damage.
Here we will be talking about another main component of the HDD, which is the spindle. The spindle is responsible for the platter so the read and write arm can access the data. The spindle motors work by generating torque, which is a twisting force so the platters could rotate at a desired speed. The HDD performance heavily relies on the spindle because the speed is a major factor in how the drive can locate a single bit of information as well as how it is being read. The spindle could sometimes rotate between 7,500 revolutions per minute to 15,000 revolutions per minute, making it much more efficient. Each platter also contains a separate ring that are used to space the platter so they can be rotated much more accurately. If the platter is not secured on the spindle, it can result into issues among the HDD, or they can even break the platter. Here we will be talking about one of the 4 main components of the HDD, which is the disk/platter. The platter is a CD type of shape where it stores all the data using binary digits. A binary digit is a bit and can express any number by only using 2 symbols, which are 1 and 0. The platter is made out of aluminum, glass, or ceramic, which has a magnetic surface in order to store its data. The platter has 3 parts to it: the protective overcoat, the substrate, and the magnetic layer. The protective overcoat is the top part of the disk where it helps minimize damage from microscopic sized dust particles. The substrate, which is the middle part of the disk, helps give the disk a much more rigid form. And last, the magnetic layer is where all the data is stored. The platter is very inelastic to thermal expansion and contraction, which helps counter the friction problem due to the high revolutions per minute. Sometimes the platter could reach up to 15,000 revolutions per minute. Many HDDs nowadays could contain multiple platters that each store a specific amount ranging from 100 gigabytes to 1 terabyte.